Hello and welcome to Talk Nurse Teach. I'm Shatara Shade and I will be your instructor today. I'm doing this video for my little baby nurses to kind of help you get through and understand the endocrine system a little bit better. So we in the same boat. I was in nursing school too. I understand what you are going through right now, my dear. Trust me when I tell you, I understand. So, endocrine system is definitely a little complicated, but heck, what is not complicated in nursing school, right? Main thing here, we want to note that the endocrine system is made up of multiple glands, as you see here, and the female and the male is presented. You have the hypothalamus, you have the pituitary glands, thyroid glands, parathyroid glands, which are located behind the actual thyroid glands. You have the adrenals, which are located right there on top of the kidneys, as well as the pancreas. And as we stroll down, the pineal gland is in the brain, but as we stroll down, you're able to see the ovaries and the testes as well. So my point for today is to kind of give you an overview of the anatomy of these structures, but also kind of correlate some of the hormones that's associated with them. So, as you can see here, these glands, the main point of these glands is to make up and create and release, messengers in the body, which we are known as hormones, right? For the most part, the endocrine system plays a major roles and have like 5 functions within the body. We know that it has a role in reproduction because we see the ovaries and the testes listed there, and the central nervous system and the development inside of children, inside of fetuses, stimulate just growth and development through childhood. When you just look at your kid and you're like, how did you just jump 3 sizes on me, right? Sexual reproduction, maintaining homeostasis and that balance within our body through those positive and negative feedback loops, but also responding to emergency demand, that fight or flight, like, hey, I gotta get up out of here. I got to move and groove, right? But let's get into it. So hormones are just chemical substance that is produced and created by the endocrine glands that we listed before. It is going to control and regulate like certain activities in the bodies by targeting whether it's a particular cell or targeting a actual organ. Some of the most like common characteristics that we're gonna think about when we think about the endocrine system is the secretion of small amounts at a varied rate depending on like what's going on within the body. Regulation those feedback loops that I was mentioning before, so just regulations of those feedback system, positive or negative. And then just the ability to bind with specific receptors like we mentioned before, like whether this is binding to a cell or actually binding to an organ. It just really depends on what you need from the body at that particular moment. So first we're going to go ahead and jump into the lovely hypothalamus, my dear. As you can see, hypothalamus is located here within the brain, male or female. It doesn't really matter, have a major difference in it. The major point of the hypothalamus, when you think of endocrine system, you say the pituitary gland is the godfather, the big dog, right? However, hypothalamus kind of has like this lovely relationship with the pituitary gland. It lies, as you can see, where it's located when you look at the pituitary gland and when you look at the hypothalamus, they're right there together, right? Like they are literally very close together because they actually communicate with each other. The hypothalamus release certain substance. They either stimulate or inhibit information, or allows the body to release a certain group of hormones that comes from the actual pituitary gland. So they work very closely together. And when you think about it, you really think about the hypothalamus working directly with the pituitary gland, and because the hypothalamus allow neurons to input from like the central nervous system. So you think in the brain stem, you think in the limbic system, you think in the cerebral cortex. And that is what we call the first like initial connection of the endocrine system to the autonomic nervous system. So that's how we're able to connect with each other and have that connection between the hypothalamus and the pituitary gland. But the hypothalamus also just kind of governs and coordinates certain type of complex behavior, such as our anger, our fear, and our pleasure, right? So we're gonna go ahead and we're gonna move on to the lovely big dog pituitary gland. If I mentioned before, pituitary gland is the godfather in this situation. So we have the pituitary gland. We can see that it's located there, close to the hypothalamus. Now, the hypothalamus, the pituitary gland is located literally at the base of the brain. It's under the hypothalamus and it's close to the splenoid bone. We have the infundibular stalk is what connects the actual pituitary gland and the hypothalamus. The stalk is able to relay that information from the hypothalamus to the pituitary gland and create that connection, what we call a very strong neuroendocrine connection. As you can see, well, you can't see here, but the pituitary gland is made up of two parts, right? We know that we have the anterior pituitary gland, but we also have the posterior pituitary gland, right? So we have those two particular glands that work together. Now, for the most part, anterior gland, probably, it handles majority of the business, right? We're going to look at the anterior pituitary gland, and it helps regulate throughout the body for releasing or inhibiting different type of hormones within the body. That is the correlation between the hypothalamus and the anterior, right? When you think about like the releasing hormones of it, you think of more so the growth hormone releasing hormone, right? It's going to tell the hypothalamus will tell the anterior pituitary gland, hey, let's go ahead and release some of these. Tell the pituitary gland, let's go ahead and release some of these growth hormones. But then we also have where the hypothalamus is able to release other hormones, where it releases the prolactin inhibiting factor, which is the PIF, and says, hey, maybe we don't need all of this prolactin anymore, and that's not necessarily produce that different type of breast milk because we're no longer pregnant or we're no longer baby feeding. I mean, not baby feeding, breastfeeding for that particular moment. Basically, the anterior pituitary gland is responsible for a certain number of hormones. A lot of the hormones that they secrete are called tropical hormones. The tropical hormones are basically going to tropical hormones control the secretion of other hormones by the gland, basically. So when you think, you're thinking of those thyroid stimulating hormones that tells the thyroid gland to release and secrete their thyroid hormones. You have the ACT, which tells you to the adrenal cortex to secrete those corticosteroids. You have the follicle stimulating hormone, which stimulates and secretes estrogen and develop like the ovum within the women, but also develop the sperm in the men. And then you have the LH hormone, which stimulates ovulation in women, but also helps with the secretion of sex hormones in both men and women. So it just really depends. Your sex does determine whether or not which hormone is being released, but different hormones affect men and women differently, whether it's to release the egg or release the ovum, but also to help produce and release that sperm. Growth hormones, as we mentioned before, they affect the growth and development of just all different body tissues of the body. An example of a growth hormone would be prolactin, right? Prolactin basically stimulates the breast development necessary for lactation after birth. This is that hormone that we're going to use to say, hey, I delivered this baby, and now it's time for me to be able to feed my child. So it's going to help the breast development and stimulate what needs to be needed for lactation, proper lactation for after childbirth. Next, we're going to go ahead and go to the post pituitary gland. We're still here, but they are both there. I wish I had a better picture, but both are there. We're going to go ahead and go to the post pituitary gland. It is composed of nerve tissues, right? So what the nerve tissues is basically, essentially, the nerve tissues slide down and is an extension from the hypothalamus. It allows that communication between the hypothalamus and the pituitary gland on nerve tracks, right? The hormones that are secreted by it is going to be the ADH, the antidiuretic hormone, and oxytocin. They are both produced inside of the hypothalamus. However, they travel down into the post-pituitary gland, and they are basically stored there until the appropriate triggers that they need to be released, right? We know that the ADH, antidiuretic hormone, is also going to be used to regulate fluid volume within the system, right? It associates with the renal tubules and say that needs either reabsorb or not absorb, making urine more concentrated or not. So that's what you think about the ADH hormone and the post-pituitary gland. The pineal gland, as you can see, little tiny pineal gland there. Pineal gland is located more so into the brain. It is composed of photoreceptors, and the reason being because the primary function is to secrete the hormones melatonin. So we know that the melatonin is going to be released in an increased amount from the pineal gland when it's exposure to dark. But we know that it also decreases in response to exposure to light, helping regulate our sleep regulations, right? We take melatonin at night to help us sleep a little bit better, increasing in our system and help us say, hey, it's dark outside, now it's time to sleep, and help us regulate our sleep rhythm for our body. However, melatonin also helps the reproductive system at the onset of puberty as well. Next up, we're going to go ahead and go to our lovely thyroid gland. Our thyroid gland, let me get back on out of here. I got fancy with my pen today, y'all. Thyroid gland. So thyroid gland is located anterior portion of the neck. So you see here where we have thyroid gland right up there, but also the parathyroid is located on the back of it, but we'll get to the back of that in a second. As you look at it, it looks like just two encapsulated lobes on each side, and it is connected in the middle. The thyroid gland is extremely vascular, but the thyroid gland is responsible to produce and secrete the thyroid hormone. So we have thyroxine, which is T4, and then we have T3, as well as calcitonin. All three of those have different things. However, T3 and T4 are influenced by iodine. As we remember, our salt is ionized. So we have ionized salts to kind of help regulate some of the iodine that's in the body to help promote the use of the synthesis really of T3 and T4. Both of the hormones are basically used to affect like our metabolic rate, our caloric requirement, oxygen consumption, carbohydrates and lipid metabolism, growth and development, brain function, and many other nervous system activities that it can be associated with. Now, when you think of calcitonin, you look at it, you think of calcium. So calcitonin is basically used to help lower serum calcium levels. And it does this in three different ways. One, it can inhibit just the transfer of calcium from the bone to the blood. Two, it can do the opposite. It can increase calcium storage in the actual bone. And then three, it can allow the renal system, our kidneys, increasing the renal excretion of calcium as well as phosphorus. Now, calcitonin has a love relationship with the parathyroid hormone and helps the PTH regulate the calcium balance in the body. So now we're going to go ahead and get to our lovely parathyroid gland. With the parathyroid, it's actually located on the back. Two parathyroid glands, but they are located behind the thyroid lobe. They say that it's 4. Some say that it can range from 2 to 6. However, it's 4 glands on the back. When you look at it and when you look at it in your book and the anatomy of it, it just looks like 2 dots on each side. That's what it looks like. 2 little buttons on each side. And the parathyroid gland secretes parathyroid hormone. The main role of the parathyroid hormone, as mentioned before, is to help regulate the serum calcium levels. What it does is it basically increases the serum calcium level by acting on the bones, the kidney, and indirectly on the GI tract. Now, one thing also, in addition to allowing the body to regulate the calcium levels, we know that calcium also loves a good vitamin D, right? So the parathyroid hormone stimulates the renal conversion of vitamin D till its most active form. And this form is basically, this form of vitamin D promotes absorption of calcium and phosphorus by the GI tract. Next up, we're going to go ahead and go to our adrenal glands. Adrenal glands are small, and you see the adrenal glands are located right here above the kidneys. It's literally located right there on top of the kidneys. Now we're gonna get a little bit closer because I want to point out something here. The adrenal glands are made up of 2 parts. it is the medulla as well as the cortex. So the inner part of it, the actual like inner part of it, say here, inner part is going to be considered the medulla, adrenal medulla. I'm sorry. And the main thing is it is to secrete the catecholamines, right? Child, I can't read today. Catecholamines today. That's our epi, that's our norepi, and that's our dopamine. It's going to release those three. They are considered the neurotransmitters, and they are secreted by neurons as well as hormones to kind of help with that the sympathetic nervous system of that fight or flight vibe is what we're looking for. Now, you look at the adrenal cortex. When we're looking at the adrenal cortex, we see what's on the outside. It literally lines the actual adrenal glands is what we're looking for. At that point, it's able to secrete several steroid hormones, including the glucosteroids, the mineralocorticosteroids, and the androgen. It releases all three of those. Different things though, certain examples of it. One of the most like abundant and potent glucocorticosteroid is cortisol. And we know that cortisol is necessary to maintain life, but protect the body also from stress. So one of the main functions of cortisol is to regulate glucose concentration by stimulating the hepatic glucose formation, glycogenesis, right? So that's one of the main functions of cortisol, I'm sorry. Aldosterone is a potent mineralocorticosteroid, and that basically helps to maintain the extracellular fluid volume. It does that by promoting renal absorption of sodium and also like the excretion of potassium and hydrogen ions. The adrenal androgen is basically when it comes from the small amounts of androgen that comes from the adrenal cortex, it basically converts to sex steroids in peripheral tissue. So it's testosterone in men and the estrogen in women. But it also has one of the most common drugs of the DHE as well. So the pancreas, let's go ahead and move on back. Sorry, I had to zoom y'all in. I wanted y'all to be able to get my point. When we think about the pancreas, we note that the pancreas here. Look how long it is. It's tapered, it's lobal, and it is literally located behind the stomach, but anterior to the first and second lumbar vertebrae. So that's what you're thinking when you think about where the pancreas is located. The pancreas has both those exocrine and endocrine functions, right? The pancreas is able to, from its islet, is able to secrete 4 different type of hormones. They are hormone secreting cells, and they have their alpha cells, beta cells, delta cells, and F cells. So alpha cells make and secrete hormone and the hormone glycogen. Beta cells make and secrete insulin and amylin. Delta cells can make and secrete. I was going to say and secrete somatostatins. The F cells, or some people also note them as PP cells, secrete the pancreatic polypeptide as well. So when we think about the difference between the glycogen as well as the insulin, we know that being that the alpha cells secrete the glycogen. Glycogen is received from the alpha cells, but it is in response to the gut. Basically said they have a low blood sugar. We just basically ingested some protein, or there was exercise associated with it. Insulin in a principal regulator is basically used to regulate metabolism, storage of ingested carbohydrates, fats, and protein. Insulin is basically, for the most part, used as a glucose transporter into cells. It also helps transport amino acids across a muscle membrane and the synthesis of amino acids into protein in a peripheral tissue. So I hope you enjoyed our overview of the endocrine system. Hopefully I will be bringing you videos 2 to 3 a week. I will go deeper in the endocrine system soon, maybe later this week. But also I want you to like, subscribe, and comment. But I want you to tell me what videos you think that you need. I hope you enjoy this, because I enjoyed bringing this to you. And I hope you have a great day. So like, subscribe, and comment. Thank you for watching Talk Nurse Teach.